In this video, we're going to talk about vertex form of a quadratic. It's a little bit different than standard form. I think it gives you a lot more information than standard form. So the vertex form of a quadratic is a times x minus h squared plus k. So you'll see that this example that I have up here, 3 times x minus 4 squared plus 1, is in vertex form for us already. So we can tell a lot about this quadratic just by looking at that equation. The first thing that we can tell is the axis of symmetry. The axis of symmetry is always going to be your h. What I want you to keep in mind, though, is that notice how the formula has x minus h. So whatever your number is that's paired with your x, in this case it's -4, we've got to remember that that negative sign is actually technically part of the formula. And then therefore, our axis of symmetry is not -4, it's +4. So x equals 4 is our axis of symmetry. Now looking at our vertex is always h comma k. So in this case, our h comma k is 4. We already identified that from part A. And then 1. The 1 corresponds with the k in our formula. Does it open up or down? Mainly focuses on the a. And this is just like in standard form in any quadratic that we've talked about before. The a always determines our width and our direction. In this case, the a is positive, so therefore it's going to open up. So opens up since a is greater than 0. Now it's asking us to graph the quadratic. So I'm going to put on this graph what we already know. We know our axis of symmetry is at 4. 1, 2, 3, 4. So I'm going to draw a vertical dotted line on my axis of symmetry. We know that my vertex is at 4, 1. So I'm going to put a dot on 4, 1. Okay, that gives us a lot of information already, but it doesn't tell us, we know that it's going to open up based on the questions, but it doesn't really give us a full graph. So what you're going to do is you're going to pick a point that is near this axis of symmetry. So the axis of symmetry is x equals 4. So I'm going to either pick 3 or 5. Totally up to you. In this case, I'm going to pick 3 just because I'm the only one here. So I'm going to pick 3. So f of 3 equals 3 times 3 minus 4 squared plus 1. Okay? So 3 times -1 squared plus 1. -1 squared is 1, so 3 times 1, which is 3 plus 1, which is 4. So an order pair that I'm going to plot next is 3, 4. 3, 1, 2, 3, 4. And then I'm going to make sure that I reflect that over on the other side. Just so that I have a decent idea, it might go off the graph, but I'm going to just check. I'm going to also plug in 2. Okay, so I'm going to plug in f of 2 as well. F of 2 equals 3 times 2 minus 4 squared plus 1. So this would be 3 times -2 squared plus 1, which is 3 times 4 plus 1. Sure enough, it's going to go off the graph because 12 plus 1 is 13. So 213. That is going to go off the graph because my graph does not go up that far. 4, 5, 6, 7, 8, 9, 10. Yeah, it only goes up to 11. So my graph does not go up that far. So I know, though, that my point over here is going to be way up here. So I need to make it super skinny. And there you go. So you just graphed your quadratic in vertex form.